So in 4-8, it is analyzing polynomials or our quadratic equations. Or is it quadratic? No, just polynomial functions. Okay. We have some key vocabulary words at the very top that I just want to point out because it is on the homework. It's important to know the difference between your factors, which you are going to multiply, and your zeros, which are things that if you plug into your polynomial function and work it out correctly, you'll end up with 0. This is also known as our solution. All right. It is also known or seen on the graph as an x-intercept. So in particular, the 0, the solution, and the x-intercept, that's something that at the very beginning I think it was in like chapter 2 or 3, I said these 4 words all mean the same thing, and then I also included the word root for the 4th word. So underneath, we're just sketching the function, and we don't need to have an exact picture of what this is. We're just getting an idea because sometimes you'll have the graphing calculator and sometimes you won't. So if you do have a graphing calculator, then by all means go ahead and plug this in. But what if you don't? What if you're taking the ACT or the SAT and you do not have a calculator? And you need to understand a basic idea of what this picture looks like so that you can hopefully better answer the question. Well, then you are going to use these tools. The first thing we need to focus on is, well, is this a positive function or a negative function? And we know it's going to be positive or negative based off of our leading coefficient, which in this particular case is that 1/6, and specifically it is positive 1/6. All right, and then we can find our solutions. We have x plus 3 equals 0, which we can subtract on both sides and get -3. So I have a point here at -3. And then also I have x minus 2 squared equals 0. I'm going to take the square root and get x equals 0, add the 2 on both sides, and I get a positive 2. Now what's important about this one is that it started off squared. And so because it started off squared, we would say this has multiplicity. Specifically, it has a multiplicity of 2. And in class, this is what I said that, if you have just one answer, like if we were to list all these, it'd be -3, 2, 2, because we have 2 of those positive 2's. Okay. If we were to do this, then we would be not crossing the line, because if we have only one of a number, we cross it. But if we have 2 of a number, then we are touching. We are just reaching down to touch it. Or as in class, I actually refer to it as booping the snoot, because sometimes people do better with that. So we boop the snoot. Boop. Okay, so the other thing we have to sort of figure out is this going to be like a parabola? Is it going to be like to the 3rd power, or maybe to the 4th power? And that is based off of our exponent. So I have one exponent here, and I technically have 2 on this one. So I have a total of 3. So a u is x squared, this little squiggle is x cubed, and x to the 4th is this. And we know that this is true because our exponent typically follows the number of turns we have. So in our parabola, we have one direction and then 2 directions. So that is why we have an exponent of 2. And then for this one, you have 1, 2, 3. So that's why we have an exponent of 3. And then finally our w, 1, 2, 3, 4. I have 4 turns, which is why I have an exponent of 4. So in this particular case, our example looks most like x to the 3rd power. So I'm going to try to follow that same idea and cross here at the -3, and then just touch down on that positive 2. So I'm just going to connect these dots. And it doesn't have to be perfect, doesn't have to be beautiful. It's just a general idea. And so we have the same idea over to the right-hand side, example 1.2. And I'm actually going to change this really fast, just so we have a little bit of variety. I'm going to make this a -1/2. So now it's negative. We have x plus 1 equals 0. That's going to be subtracted to give me x minus 1. We have one of those, so I know I'm just going to cross through it. And then we have x minus 4 squared equals 0. Take the square root, and we get x minus 4 equals 0. Add 4 to both sides, and we get positive 4. And so this one, we are, again, not crossing. We are actually booping the snoot. We're going to boop, touch down or touch up or whatever. And since I changed this to be negative, okay, that's not what it is on your nose, but we're changing it now. I just need to figure out, is it x squared, is it x cubed, or is it x fourth? Well, this is 1, and again, this is 2, so it's going to be like this picture on the left-hand side that I just circled. And so what I'm going to do is I need to make sure that my final piece or my final arm is going the direction I need. So in example 1.1, because it was positive, the right-hand side is going upward. And that's how I know it's positive. So that means for this one, I know I need to be going downwards because that makes it negative. This is also where I'm booping the snoot, all right? So I'm just touching right there. So it's going to be going up and looking something like this. Again, not beautiful, not perfect. It's just a general idea of what's happening. In class, I switched this around, but I'm going to go ahead and do this really fast. In the next portion, it has a little bit of vocabulary right here. It talks about the turning points. The turning points are one of the most important pieces of this next section. Specifically, a turning point is obviously where we change directions. So when we change directions, we're going to end up with a maximum or a minimum, or something called a saddle point. And the saddle point's not really something I'm going to focus on in this particular class, just because it's not super important. And there's just better applications for maximum and minimums. But you can have multiple maximums and multiple minimums. Please make sure that you understand the difference between them. A maximum is like the peak of a mountain, and a minimum is going to be a valley, where the valley is. All right, so what I'm going to do in example 2.1, it has a lot of instructions. It says graph the function, which I want you to do on your calculator. Then it says identify the x-intercepts, the points where the local maximums and minimums occur, and determine the intervals for which the function is increasing and decreasing. So the first thing I'm going to do is I'm actually just going to write down all the things I need. And this is, again, a little bit different than your notes because I haven't updated them yet. But I need my x-intercept, it's from right here. Then my local maximum and minimum, so I'm going to say L maximum. If I just had maximum, then that would just be the highest or the lowest. Okay, and then my increasing and my decreasing. And I do want to say that it is possible to not have a maximum or a minimum. That is a possibility. So if you have that in your homework, I don't want you to feel like that's not a possibility or whatever. Anyway, so now that I have this, I'm going to go to my calculator and I'm going to plug in the equation, which I've already done. So this is what it should look like, or something similar on your calculator. And then I'm going to click on graph. So now I have my picture. Well, typically in this section, we've been doing all this by hand. But if you look closely, I actually don't have exact numbers. My x-intercept right there is just left of -1. And so because of that, what I'm going to do is I'm going to click on my calculator so that it'll do the work for me. And how I do that is by pressing second trace. Second trace leads me to the calculate menu. And I can see that I have the three main items that I need. A 0, which is the same thing as a x-intercept or solution, a minimum, and a maximum. So the first thing I want to look for is that 0. So I just pressed 2 really fast. And now you can see sort of this blinking star at the very top. And what I'm going to do is I'm going to move that star, and if you have an older version of the calculator, it looks like an X. But I'm going to move that star to get as close as I can to the intersection, which seems to be here. And once I get here, I'm going to go to the left one time and press enter. All right, go back and go to the right one time and press enter. Now, basically what's happening is the calculator is infinite, right? I mean, just because it's not showing you anything doesn't mean that the calculator doesn't have it already ready to give you in case you ask, in case you wanted to zoom out or whatever it may be. So by doing this process, going to the intersection, going to the left one, pressing enter, going back to our x-intercept, going to the right one and pressing enter, it's basically cutting our infinite graph into a tiny little piece so that the calculator can just focus on this little portion. All right, so if you do not have this correct, then it's going to cause some issues. Another thing I want to point out is that at the very top you have your arrows. The arrows show you that it's focusing right in between on this little sliver. So it's only looking in here. So if you end up with like an arrow facing this way and the arrow facing that way, then your calculator is looking in opposite directions and it's not going to be able to find your answer. It'll probably say error of some sort. But the last little question at the bottom says to guess. You don't have to guess, just press enter again. And it gives you your 0. It actually gives it to you as an ordered pair. Anytime you have this, go ahead and round to 1 decimal place. I think the homework on the Big Ideas website rounds to 2 decimal places, but for me, it's just better if we round to 1 decimal place. So this is going to end up saying negative 1.2, comma 0. And that's if I wanted to write it as an ordered pair. But since it's my x-intercept and later on I'm going to have like a multitude of x-intercepts, I'm just going to write it as negative 1.2 as a list, really. All right, so that is my x-intercept. Pretty easy. Let's go back and find my maximum. So I have second trace. My maximum is number 4. Make sure you click on that one. And then I'm going to go to the maximum. If you want to do the minimum first, you can. It doesn't really matter. But here it looks to be my maximum. And so I went to it. I'm going to go to the left once. And now it's still really close to the maximum. And it may be a little hard to see that it is, in fact, to the left. So I'm going to go to the left one more time. Press enter. All right, go back to my maximum. I'm going to go to the right. It's still a little too close, so I'm going to click to the right one more time and press enter. Anytime you're doing this, the most that you should be pressing to the right or to the left is twice. You really shouldn't go any farther than that. Then you press enter again, and it has a maximum of 2.9212E. Okay. E is another way to do our scientific notation. So notice down here, this is where it says E. This is scientific notation. So if I wanted to, I could write this out as 0.000000292. Yeah, I could do that, but that's a lot of work. And so for my class, anytime that you see E, go ahead and rewrite that as just being 0. And then at the very bottom, I see that my Y value is 6. So my maximum is at 0.6. All right, almost done. Got to keep going and find my minimum. So I'm going to press second, trace, and then my minimum is 3. Again, make sure that you are clicking the right one. So this is going to say 3. I think I'm at the minimum, so I'm going to go to the left. It's a little hard to see, so I'm going to go one more time. Remember, 2 is your maximum. Go back to your minimum. 1, 2 is your maximum. Press enter, enter. And I get a minimum of 2.2. Now, it's okay if you end up with 1.99999. That is going to round to 2. It's also okay if you get 2.0000001. I think that was one of them that I had today. That also rounds to 2. So please don't worry that, if your window's too big, then you're going to end up with the wrong answer. That's not the case. Because of where I'm asking you to round, you should always end up with the same answer as me. Okay, so we have found the easiest pieces. It was just calculated work. Now we need to find our increasing and decreasing. And the increasing and decreasing is based off of our picture, which looks like this. Okay, maybe not exact, but it looks something like this. I can see clearly that I have a turning point at 0 and a turning point at 2. And I know that they're turning because originally it goes upwards, then downwards, and then upwards again. So what we're going to do is we are going to write this in, not scientific notation, interval notation. All right, so I am going to use the skill that we did and that we learned right before chapter 4, which was when we did our inequalities. Now, the textbook requires you to do inequalities. However, I know for a fact that in our area, when you go off to dual enrollment or college and you take college algebra, they do not do your inequalities. They teach it as interval notation. So I just want to make sure that everybody's prepared for that. So here's my number line. Okay, as I said before, over here it's going up, over here it's going down, over here it's going up. And I'm going to write my interval notation. Just imagine that you have an open dot over your numbers, And if you are going to the left, if you're on the left-hand side like this, then that's going to be from negative infinity to 0. If you were going to the right, it would be from 2 to positive infinity. And if you were in the middle, connected, then it would be 0, 2. And so now I have written all of my interval notations, and I'm going to bring them over into my answer. So I said that negative infinity to 0 was increasing, so it's going to be negative infinity to 0 is increasing. The next portion was decreasing, which we said was 0, 2. And then the other piece is 2 to infinity, and that is also increasing. Just make sure anytime you have more than one item on the same line for increasing and decreasing, your interval notation is connected with a U. So just make sure that that is connected. And that stands for or. So you are either increasing from negative infinity to 0, or you are increasing from 2 to infinity. Okay, so it's an interesting concept. Again, the first three things is not difficult. It's just keeping things organized whenever you go to write your increasing and decreasing. And we are going to spend a whole day practicing this, because I do know that it's a new concept. I mean, maybe not completely new, but it is a new way of writing our increasing and decreasing, because I know you technically do increasing and decreasing in Algebra 1 with your with this textbook. All right, so we're going to go ahead and plug in the other equation. So here is our equation plugged in, and please note that I did adjust the notes. So if you don't have the updated notes, then please don't think that you are going crazy or you're doing something wrong. I did update the notes, so it does look a little bit different. So this is technically, if you have the old notes, it's example 2.1b, but I made it 2.2a. Okay, so we're going to graph this. It should look like this. And we can see that we have a minimum, but it's actually off the screen. Quick little note, let's say that you don't see all these items. You can always go to Window and make sure that your minimum and maximum are -10 and +10 for both your x and your y. That's something that you can quickly, fix in case you have any sort of issues. So let's go back to our graph, and we're going to find all of our intersections. Really doesn't matter what you do first, but I like to go one at a time, make sure I'm doing my process correctly. So I'm going to click second trace, and I want to find my zeros. All right, so I'm going to go to my first 0 here on the left. Ooh, well, I passed it. All right, I can't even get close to it. That's fine. I'm going to press enter. All right, I went to the left, pressed enter, and now I'm going to go to the right. Okay, if you're a little worried that it's not going to include it, you can press to the right one more time. Don't go past 2. And now I can see that my intersection is inside of that dotted line. So I'm going to press enter one more time, and I get -1.1. And then look off to the right. Y equals -1e. Remember, anytime you see e, that's technically 0, which makes sense because it's an x-intercept. So of course y is 0. So I'm just going to write that down as a mental note, and I'm going to write everything at the end. So that's the first intersection. I'm going to do all this again for the second intersection. Okay, so I'm going to the intersection, going to the left one, enter, back to the intersection, to the right one, enter, enter, and I get 0 point rounded 3. All right, one more time. Second trace 2. All right, going to my intersection, to the left 1, go back to the intersection and go to the right one. Enter, enter. And I get 1.8. All right, there's one more. It's off to the right, and I'm going to lose my little blinking star for a second, but it's going to be fine. So second trace 2 for 0. Okay, I'm going to go this way, and I'm just going to trust that it's coming back. And you can actually see the values changing here at the bottom. So you'll be able to see when it's coming back with the y. So I'm moving that, and it's going down, 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 down. Oh, wait, it was just at 43, see? And then it's coming back up. So now I know it's coming back up. Keep going up. There it is. So it's going to be enter. And then to the right, it just went off. It probably went way up here somewhere. So we're just going to press enter, enter again, and I get 5.0, which rounds to 5.0. Okay, so let's go back to our notes and write those values down. We had x equals negative 1.1, comma, 0.3, comma, 1.8, comma, 5. And you can put 5.0 if you want. It doesn't really matter. I personally don't care. Some teachers do, some teachers don't. Doesn't matter. All right, and then we need to find our maximum. Okay, so thankfully, x-intercepts were the most, so we're just going to go back over here, and we need to find our maximum. So second trace, 4 for maximum. I'm going to go back over to the left. Okay, there it is. Remember, go to the maximum, and then go to the left. Okay, I can't really tell that it's not on the maximum, so I'm going to press the left one more time. Enter. Okay. And then I'm going to go to the right. Okay, I can clearly see it's to the right now. All right, so my maximum is 1.1 and 5.1. So I'm just going to write that down. 1.1, comma, 5.1. Okay, keep going. We have 2 minimums, so we're going to do second trace. Minimum is 3. I'm going to go to my minimum on the left, and okay, I think this is the minimum. So I'm going to go to the left once, enter, back to my minimum, and then I'm going to go to the right. I can't quite tell with that one, so I'm going to go one more time. Remember, 2 is your maximum. And then press enter twice, and we get negative 0.5, or excuse me, negative 0.6, because it's going to round, comma, negative 6.5. Okay, so I'm just going to write that down in a second. But now I need to find my other one. So this one's going to be interesting, but we'll be okay. Second trace, 3 for minimum, and I'm going to go over here. And even though I can't see it, I'm going to still be able to find it. And so I'm just going to try to get as close as I can while I can still see it. Okay, I can see here. Yep, and disappeared. All right, so I'm going to put my bound here, and then I'm going to go to the right until I see my star again. Oh, there it is. Okay, so that's my star. Press enter. It wants me to guess. Okay, sure. Yeah, I'll just guess there. Okay, so I see that it's going to be 3.96. That's going to round to 4.0, comma, negative 43.0, which would be 43. Okay, so I'm going to go back here, and I'm going to write the first one. The first one was a negative 0.6, comma, negative 6.5, and 4, comma, negative 43. Okay, so I found all the pieces. Now I need to find my increasing and decreasing. Something to note really quickly is that in our previous picture, we were able to get 0 and 2, but notice that they were the same exact values as our x values for the local max and the minimum. In our current problem, it's not a beautiful whole number. It's not like 0 and 2. We have decimals to deal with. And so if you're ever concerned about which numbers to use, go ahead and just highlight the x values of your local max and your local minimum. These are the values you need to use. So I'm going to just quickly sketch what this picture looks like. It's going to look something like this. It goes down really, really far. Doesn't really matter. I'm going to quickly get an idea of what's happening here. This is going down and then up, down, and then up, okay? So I'm going to put my number line above. And remember, it's based off of your turning points. So my turning point here is negative 0.6. And I know it's going to be negative 0.6 because that's the only negative x value that I have. Here I have another one. That's going to be 1.1. And then here I have another turning point. So this is going to be 4. And now I'm going to write my interval notations. So again, think about this as an arrow or open dot with an arrow going to the left. So that's going to be negative infinity to negative 0.6. And I said it was decreasing, so I'm going to write that in my decreasing area. Negative infinity, comma, negative 0.6. All right, next one is in between two numbers. So I'm going to put my two numbers together. Oops, it should be negative. negative 0.6, comma, 1.1. And a really good question that somebody asked me today was, are we going to have brackets? And the answer is no, not for this section. So you don't have to worry about brackets in this one, because that is a thing you have to do with the other ones. All right, again, that one is increasing. I know it's increasing because I put it was increasing over here, and this area corresponds with that area. So that's why that's going to be increasing. So the next portion is decreasing, and again, it's between two numbers, 1.1 and 4. So 1.1, comma, 4. So I'm going to go over here. It's decreasing now. Remember, if I'm connecting to, I'm going to put a U to represent or, 1.1, comma, 4. And then our last one, again, think about it as an open dot with an arrow going to the left. So it should be 4, comma, infinity. So this is going to say or 4, comma, infinity. And now we have completely done our increasing and our decreasing. So don't worry, we will be practicing this a lot tomorrow. We have a whole worksheet for it. So let's go to our last little section. Okay, so in this particular section, I just feel like I didn't teach it very well the very first time, so I just want to take a second and go through it one more time. I realized after listening to me teach this section, because I was a little worried about it, that I didn't teach it incorrectly, but it was a little confusing whenever I was trying to describe what happened. So we're going to try it a little bit differently this time. Again, with our even and our odd functions, remember that in order to do this, we are plugging in a negative x, and that means we're going to have 3 possibilities that are going to occur. We're either going to end up with the same equation that we started off with, which means it would be even. We could end up with a complete opposite, which would make it odd. Or we could end up with neither of those, and we would just say the answer is neither. And when we're talking about the same or the opposite, what we're really looking at is our signs. So in example A, we start off with positive, and then we have negative, okay? So if I were to plug in, let me go ahead and do that, plug in my negative x here, like this, then if I end up with, again, a positive followed by a negative, then I have the same equation I started off with. So let's just go ahead and do this. There's a couple different ways that you can think about this. If you are a visual person, I strongly recommend rewriting this as negative x times negative x times negative x. That's 3 times, right? So we have 3 negative 1s, and then we have 3 x's. And so from here, we should be able to say, oh, this is going to be negative 1 times x cubed, or negative x cubed. All right, so that's one way. And I strongly recommend that if you are struggling with this section, to go ahead and do those extra steps. It's not going to hurt you. Or if you do the work and you feel like you're unsure of your answer, then again, I would suggest to do this as a second option, if you will, so that you can make sure that you are doing this correctly. But the easiest thing that I think you can use is just use your calculator. We have a monomial, which means we can distribute our exponent here. So this is going to be negative 1 cubed. If I plug that in my calculator, I get negative 1, technically, x cubed. And then over here, technically it's an understood exponent of 1. So I mean, if you wanted to, you can plug it in as negative 1 to the first power, but whatever. But either way, you're going to end up with a negative 1. Negative 1 times a, let me write it out. Negative 7 times a negative 1. Let me get rid of my parentheses. Negative 1 x. Well, 2 negatives make a positive. So it's going to be negative x cubed plus 7x. Okay, so let's examine the signs. At the beginning, we had positive followed by a negative, but now we have a negative followed by a positive. It's the exact opposite. And since it's the exact opposite, we would answer the question by saying that our function is odd. And again, the whole purpose of this is, what if they ask us if this is an even or an odd function and we don't have a graph or a graphing calculator? What would the steps be? It would be these steps. okay? So let's do another one. All right, we end up with positive, positive, and then negative. That's what we start off with, all right? So we're going to plug in x to the fourth plus parentheses squared minus 1. Okay, I'm plugging in that negative 1. I'm distributing. Okay, so that's going to give me negative 1 to the fourth power. Negative 1 to the fourth power is a positive 1. So this will reduce to x to the fourth plus negative 1 squared, which is positive 1, x squared. And then anytime you have a constant, just carry it down. So this started off as positive, positive, negative, and it ended as positive, positive, negative. It ended with the same exact order of our signs. So this will be, it'll be even. It'll be an even function. All right, so we've seen an odd function. We've seen an even function. So what about a neither function? What if it's neither? Well, that's what letter C is. So I'm going to rewrite this. And before I do, I'll just note this is positive and then positive. So that means in order to be even, they would have to be both be positive at the end. Or if it's odd, they would both need to be negative. Anything besides that, it's going to be neither. So I'm going to rewrite this x cubed, and I'm just putting blanks because that's where I'm going to plug in my negative x. I am distributing that exponent of 3 to the negative 1. That's going to give me a negative, negative x cubed, and carry down the constant. So I have a negative and then a positive. Well, that's neither odd nor even. So that's why we would say this is neither. All right. Let's look at the example 3 then. This is our last little section. In example 3, it's the same idea. I'm going to make it a little bit bigger so it's easier to read. This caused a lot of issues today, so I just want to make sure we take time with that first one. So the first thing we're going to do is we are going to rewrite it, and we're replacing that old x with the new x, negative x, all right? All right, I am going to take that squared and distribute. This is going to be carried down along with the plus 5. So negative 1, let me point that out, negative 1 squared gives me a positive number. All right, so this is going to be positive x squared. But notice that the negative was already carried down. So really, it's negative x squared plus 5. I'm just carrying it down because it wasn't a part of my parentheses. It was just part of my equation in front, not within the parentheses. So that's why it's being carried down the whole time. So this is going to be my final answer. I can come up here and just double check. It started off positive. It started off, what is that? I can't even read it. There we go. It started off as negative, and then it was positive. Negative, positive. So then down here, it was again negative and then positive. So it's the same thing as we had before, and therefore this function is even. All right. The one beneath it, same idea. Put my parentheses. I'm just rewriting my equation first so that I can get used to it. Negative x. Take that 4, distribute. Negative 1 to the fourth power is going to be a 1, positive 1. So it's x to the fourth. And then right here, this 3 is going to distribute, and I'm going to be left with a negative 1 x cubed. Well, now I can see that I have negative 5 times negative x. So I'm going to carry this down because I already worked with it. This is going to become positive 5x cubed. All right. So if I look at the starting point, it was positive and then negative. But down here, it's positive and then positive. It's not the exact opposite, and it's not the exact same. So we would say this is neither. All right, last two. We're taking this, replacing it with a negative x. Distribute that exponent. Negative 1, negative 1 to the fifth power is going to be a negative 1 times negative 1, x to the fifth power. 2 times a negative 1 gives me negative 2, x to the fifth power. I mean, this started off as positive and it became negative, and there's not a constant, there's nothing else to really consider, so it is in fact the exact opposite. So therefore, this is an odd function. All right, last one, positive, positive, negative. That's where we started. Now let's plug in. All right, just rewriting all my stuff and plugging in negative x. The 3 is going to distribute. I'll get 2 times negative 1, because negative 1 to the third power, when you use a calculator, is still negative 1, x to the third power. All right, then we go to the next one. Oops, too far. X squared goes, the squared goes to the negative 1 and to the x, excuse me. So we're going to carry down that plus 8. Negative 1 squared is going to be a positive 1, x squared, and then carry down your constant. So the first little bit right here, negative 1 times 2 gives me negative 2x cubed. Then 8 times 1 gives me a positive 8x squared, not cubed, squared. Carry down your constant. So originally it started off as positive, positive, negative, and then it ended as negative, positive, negative. So it's not the exact same, and it's definitely not the exact opposite. So again, this one is going to be neither. All right, so hopefully that was a little bit clearer for you guys. And if you have any questions, remember, you can always email me or text me on Remind.